Okay, what's up everyone? Um, it's our second video session. Okay, we are already done with weeks 1 to 3. Now we are going to talk about the applications sa inyong mga na-learn or na-achieve sa unit learning outcomes. I hope na you already achieved those, no? Because we already had our exams and I'm very glad na most of you have passed. So for the next topic, which is the application. So we have this as under our unit learning outcomes A. So recall and solve the types of first order differential equation application. Okay. So that's your ULO A for the 2 weeks na tuwang itakel. So we have four first order differential equation applications. So we have the growth and decay, which is our first topic. Naman itong istoryaan karon. The second one is Newton's law of cooling and heating, the mixture of two substances and electric circuit. And I believe that kanisha, the four applications are very essential in engineering applications. No? So this will enhance your critical thinking skills as future engineers. Okay, now let's talk about growth and decay. So what is growth and decay? So the term growth and decay is not limited to the growth of a population and its decay. So dili lang siya population growth, no? And decay. So it can be increase and decrease of a certain substance, loss and gain of a capacity. So substance, capacity, and so on. Okay. So we have this dE, no, that will describe any growth and decay. So dP over dt is equal to Kp, where dP over dt is the growth and decay rate. So that's the rate at time t. Population, which is the P at time t, and K the constant of proportionality. So here, we can solve the general equation sa differential equation, di ba? So that's the application of variable separation. So integrate both sides, integrate this one, you will have this. Okay, so dP over dt is equal to the integral of k dt. So you will now have the ln of P is equal to kt plus C. So that's how your general equation is sa growth and decay. So for the first example, alright, para mas masabtan na to for the first example. So a bacteria culture starts with 500. So sinugdanan pa daw na natay 500 ka bacteria. So after 3 hours daw, it became 8,000. So naging 8,000 yung bacteria. The question is, you are going to find the number of bacteria after 4 hours. Okay? And when will the population reach 30,000? Okay, first question. Find the number of bacteria. That's the K. That's the population. Number of bacteria, that's P. Okay, that's P. And letter B, when will the population reach 30,000? This is T. Okay, so T, ang ginapangita sa B, well, whereas sa A is your population at 4 hours. P at 4 hours. Okay, so yes, we have the equation here. Ln of P is equal to Kt plus C. That's our equation 1, right? Equation 1. So, guys, remember that our population started with 500 bacteria. So, with that, we can easily substitute. And then, we can get C. So, sa 500 na population, of course, initial population, the time there is 0. Okay, 0 yun ang time. Initial man. So, since sinugdanan pa, meaning wa pa nagsugod ang tanan. So, 0 ang time. Nag-start ang population as 500. Then, after 3 hours, the bacteria grown sa 8,000 kabuok. Okay? So, we can solve for the value of K here. So, sa 8,000 daw na population, we have time na 3 and the C, which is ln of 500. Okay? Now, you can solve the K. Makuha na nato ang K. So, at this point, we can observe that all the constant variable from equation 1 has its respective value, so we can solve any situation in the problem. So, makuha na nato ang letter A, the population at 4 hours. So, ln of P is equal to K, which is this one, times the time na ginapangita, which is 4 hours. 4 hours on time. Okay, that's time here, plus the constant, which is the ln of 500. Okay, now we can get the population, which is approximately 20,160. So ang population daw sa bacteria after 4 hours will now be 20,160. Okay, for question B, when will the population reach 30,000? So ginapangita ang time t. So, of course, natatay population, diba? ln of 30,000 is equal to, we have k, 1/3 ln of 16. That's our k, tama? And the time t right here. Okay, guys, remember, you can have this one as decimal, wala problema. Nag-vary ba ang decimal points, but it's not a problem. So, ayaw lang sa ninyo siya, uh, do not round off your decimal numbers yet until sa final answer. Okay, so I suggest you save it sa calculator, sa constant A ba, sa B, sa C. So you save it and then round off your answer sa final. Okay? So again, ln of the population, which is 30,000. Your K is ln 16 over 3, and your constant is ln of 500. So you can have the time as approximately 4.43 hours. So at 4.43 hours daw, mag 30,000 ang population sa bacteria. Okay? Alright. So let's have another scenario. Suppose the population of insects increases according to the law of exponential growth. So law of exponential growth, again, ln of P is equal to KT plus C. So there were 130 insects at the third day of the experiment. So sa third day daw, nanaday 130 ka insect and 380 insects at the seventh day. So approximately how many insects were the original population? So the question here is the original population. Asa nagsugod ang all? Asa nagsugod ang tanan, no? Unsa na population ang insect pagsugod? Okay, so remember again that we have ln of P is equal to KT plus C. So ln of P, the population at 3 days was 130 insects. So you can have C is equal to ln of 130 minus 3K. Okay, then for the next event, 380 insects. ln of P, ln of 380 is equal to K. Ang time ana 7, so 7K. So, this is your equation 2. Okay, remember, sa inyong algebra, if you have this one, you can use the substitution method. Diba? Substitution method, equate both sides. So, si ln of 130 daw, minus 3K is equal to ln of 380 minus 7K. So, guys, you can shift solve. You can use your calculator. Okay. So, to get the K here, you can shift solve, or yes, you can mano-mano it. Walay problema. You can use your calculators to get K. So, you will now have K as 0.2682. Alright, I think, yeah, again, do not round off yet. Do not round off yet. So, again, ln of 130 minus 3K or 3x sa calculator is equal to ln of 380 minus 7x. Shift solve. So you will have the answer of 0.268,159,2006. So you round it off after you get the original sa final answer na lang. To be safe, just to be safe. Okay. Then for C, you can substitute no to get, di ba, na kay K. So you can easily substitute here sa equation 1 or equation 2. So wala problema kung asa na may substitute, you can get the same answer. So you just choose one of them. Isa lang gid ang pilion, no? Okay. So substitute ln of 130. So equation 1 ako ha. Substitute C. Okay, to get C. Minus 3 times your K, which is your answer, 0. Okay, so you will have your C as 4.60630568849. Okay, so you have both C and K now. You have both C and K. So now we can determine the initial population of insects using the formula ln of P is equal to K T plus C. So ln of P, initial population, so our P is unknown. Your K is given here. Okay, K is given. Then ang time na to, okay, ang ginapangita again is initial population. So obviously you have time there as 0. Plus the C, which is this one. Okay, using calculator, you can have the population as approximately 58 insects. Okay? Alright. So, guys, I will be posting a forum to answer all your queries sa topic about growth and decay. Okay, I think yeah, this is very understandable, and I think this is the one of the easiest applications sa differential equations. Okay, for your seat work, please answer this one. The table below shows the rabbit population on a certain island where T is the number of years, beginning with the year 2000. Determine the relative growth rate, general equation for the population. So guys, I recommend na sa general equation, you simplify. Okay? And then estimate the population in 2010 and how many years will it take the population to double. So please answer it, and I will upload an assignment tab sa inyong Blackboard. Okay, so thank you for watching. I hope you have learned something from this. Again, if you have questions, please post it sa forum na ko i-post. Thank you and have a very good day.